Earth, rotating in space, 22,000 miles away. The perspective is one that shows us how interdependent the natural systems that support all life on the planet really are. Everything actually is connected to everything else. The sun, prevailing winds, and climate conditions compel the movement of sea surface ice and continental snow masses. Vegetation grows and declines as these systems advance and retreat. The temperatures of the great ocean's currents both drive and are driven by these global weather patterns. The Earth is breathing and in balance. The Earth is alive. But a threat to this delicate balance is now growing in the Earth's atmosphere. It is now growing less permeable as a result of air emissions from a variety of human activities powered by the combustion of fossil fuels. Although the sun's light still penetrates, its reflected heat from the Earth's surface becomes trapped, raising the ambient temperature of the globe. The majority of scientists worldwide agree that global warming is now taking place, and most agree that it could have potentially serious consequences for all life on the planet. Human activities in our largest population centers, the cities, account for the vast majority of these global greenhouse gas emissions. As the world becomes more urbanized, this phenomenon grows. In the United States, the situation is especially evident. Today, 80% of our population lives in urban areas, and more than half live within the 25 largest cities. American cities and towns now account for over 80% of our national energy use, and urban land use development affects 70% of that consumption. As our urban centers expand at the edges, low-density residential, commercial, and industrial developments claim previous agricultural, forest, and open lands. And from a resource use standpoint, this development consumes 85% more energy, 70 times more water, 50 times more lumber, and 40 times more land than higher density developments of equal size. To sustain the diversity of life on the planet, we must change the way we relate to our shared environment and the way it relates to us. Change the way we design, develop, and manage our cities and the way we conduct life in them. This presentation provides a model for that transformation. A shift from communities that consume and degrade our natural resources to communities that consciously sustain them and improve the quality of all life on the planet. 5 overriding principles guide this design. 1. The need to utilize all potential sources of energy while controlling all energy-related pollutants. 2. The need to maximize the benefits of natural systems such as wind and water flows, sunshine, precipitation, and the absorbency of land and vegetation. 3. The cooperation and involvement of the community in the everyday management of resources. 4. The need to allow higher concentration of mixed-use development across our cities. 5. The establishment of equal opportunities for all residents to affordable housing, social services, and access to efficient transportation. The subject for this design is the Greater San Diego-Tijuana Binational Metropolitan Region, chosen to emphasize the importance of a region-wide air and watershed basin approach to sustainable development, regardless of jurisdictional borders. Today, the region supports a population of approximately 4.3 million people. They reside in the city of San Diego, the municipality of Tijuana, 17 additional incorporated cities and unincorporated areas of San Diego County, as well as the Mexican cities of Tecate and Rosarito. Like most urban communities, this binational metropolitan region is growing at an ever-accelerating rate, with the current population expected to soar to 8 million by 2030, and more than 15 million by 2103. Under a business-as-usual approach, this growth will far exceed the current infrastructure planning, financing, and land available for development. And much of this development will be at the expense of ecologically sensitive land, animal habitat, and the remaining farmland. Other essential resources such as imported water and energy, the extremely limited stock of affordable housing, and air quality will also be heavily stressed. We now venture into an alternative, sustainable future for the region. A future that accommodates projected population and economic growth without degrading the natural environment. In our design for the San Diego-Tijuana metropolitan region, there are 4 urban zones centered on or near Escondido, Sorrento Mesa, downtown San Diego, and downtown Tijuana. Each of these zones contains a hierarchy of primary and secondary cities, surrounded by clusters of smaller villages and their neighborhood communities. We'll focus on one of these urban zones, located on the international border. Approximately 15 miles in diameter, the zone's primary cities accommodate 750,000 to 1 million residents in densities of 122 to 162 units per acre. Secondary cities accommodate 1/3 fewer residents. Villages are approximately 2.5 miles in diameter and accommodate 40,000 to 65,000 residents at densities ranging from 12 to 75 units per acre. The highest population densities are in the city and village centers and along transit corridors that radiate from them. These areas support a diverse mixture of affordable housing, retail and business establishments, employment and educational centers, and cultural and recreational facilities. They also serve as the hubs for the regional transportation system. Surrounding each village is a set of 6 to 8 neighborhood communities, ranging in size from 250 to 310 acres, and accommodating 6,000 to 11,000 residents. Once again, the highest residential densities are found at the neighborhood center with 50 units per acre. These highly walkable neighborhood centers offer easy access to elementary school, shopping, and religious institutions, and civic and office buildings. In the outer edge of the neighborhoods, residential densities taper off to only 12 units per acre. But a sense of place, engendered by homes of the past and historic districts, remains. Blended wing and vertical takeoff and landing aircraft, marine hovercraft, and high-speed magnetic levitation rail provide the principal means of travel to and from the region. This same rail line also connects the primary city centers within the region, as does a network of express flex trolleys connect the primary and secondary cities across the region. Traveling at speeds of up to 50 miles per hour, these computer-guided trolleys move along dedicated guideways, serving stations 3 to 3.7 miles apart in 5 to 10-minute intervals. Providing service between the cities and their outlying villages is a local express version of the same trolley system, although operating at lower speeds and serving stations spaced every 1 mile apart. The primary transit service between cities and their immediate villages and neighborhood centers is a 3-tiered system comprised of a city-to-village tramway, a village-to-neighborhood feeder line, and a network of inter-neighborhood shuttles. Together, all of these fuel cell-powered electric vehicles quickly and conveniently move residents across the region, emitting only water vapor to the atmosphere. Complementing this public transit system is a private mobility vehicle, or PMV system. Ranging in size from 2 to 10 passengers, these fuel cell-powered, computer-driven vehicles provide point-to-point transportation on demand from a centrally housed and maintained fleet. Fully automated PMVs enable passengers to set the destination and then relax or focus on other matters, while the vehicle propels itself along sensor-laden guideways. Also available are dual-mode PMVs that allow passengers to take an active role in the process and to travel off of the guideways to remote locations. Most commercial enterprises also use a modified version of the dual-mode vehicle. This combination of public transit and PMV systems provide residents choice, convenience, and emission-free mobility, and effectively replaces the personal and commercial vehicles of the 21st century. Most of the region's energy and environmental systems are now located close to the populations they serve. This is made possible through the miniaturization and integration of these technologies and their co-location in residential neighborhoods at the Resource Management Center, or RMC. From the exterior, the RMC appears to be little more than an attractive 2-story civic building. But on the interior, An impressive array of technology generates, stores, and controls the flow of the neighborhood's energy and receives, reclaims, and recycles its water and solid materials. As we approach the RMC, we notice the expansive array of solar, photovoltaic, and thermal panels that shade the building's elevation. They are producing both energy and hot water for the surrounding community, while they cool the building's interior. We also notice a rooftop plaza capped by a curious antenna. What appears to be moving just above the plaza are rotor blades of a highly efficient wind turbine, converting the coastal airflow into energy. What appeared to be a two-story structure from the exterior is now clearly an expansive four-story structure, with two below-grade floors now visible. Before descending further, we see the neighborhood's PMV fleet operations and maintenance center. Here the PMVs are refueled with hydrogen, produced by the wastewater treatment facility below. The PMVs also share their electrical energy with the RMC's battery banks and serve as mobile sources of electricity for remote activities outside of the neighborhood's electrical microgrid. Private companies maintain showrooms on the PMV level, enabling neighborhood residents to choose from among a variety of models and amenities available to customize their annual PMV leasing programs. And sophisticated computer systems are housed here that manage both the PMV system and the two-way flow of energy between the RMC and its residential and commercial users, and the region beyond. At the ground floor level, we see an extensive bank of hydrogen fuel cells. Along with renewable technologies, these fuel cells are the combined cooling, heating, and electricity generation source for the neighborhood. These cells are electrochemical devices that directly convert hydrogen or hydrogen-rich fuels into electricity without combustion. Although they resemble batteries, fuel cells never need recharging or replacing and can consistently produce electricity as long as they are supplied with hydrogen and oxygen. This process is much more efficient than traditional thermal power plants, converting up to 80% of the chemical energy in the fuel into electricity. Heat from the fuel cells is collected and sent a story below to aid in the drying and vitrification of sanitary solids. The heat is also used to chill water for district cooling uses in the neighborhood. Sanitary water flows from the community are received at the RMC through separate gray and dark water intake pipes. Utilizing an electrical current from the RMC's solar photovoltaic system, the gray water flows are electrolyzed to produce hydrogen and oxygen for the fuel cells. Dark water flows are sent to an anaerobic decomposition chamber where bacterial processes produce both hydrogen and methane. Some of this methane is reformed to produce additional hydrogen, while the balance is burned in a glass furnace that turns the remaining sanitary solids into a molten hot material. This material is then quenched in cold water to produce a fine glass aggregate for use in the production of building materials. Recycling of sanitary solids in this manner proves to be far more sustainable than the use of these solids as an agricultural fertilizer, which only recycles trace metals and salts back into the food chain. All remaining waters from this system are then blended and purified with the other major water supply in this particular metropolitan region. At the lowest level, salt water reaches the RMC through a network of inland distribution centers fed by coastal pumping stations and powered by inline micro-hydro turbines. The salt water is sent through an energy-efficient capacitive deionization filtration system utilizing membrane-based seawater treatment technologies. The output is potable drinking water, as well as solid blocks of salt. The water is fed back to homes and businesses through a network of underground pipes, while the salt is sent to regional collection centers for use in a wide variety of industrial processes and commercial products. Essentially, all waters in the region are now recycled for multiple uses. Although the RMC produces most of the energy to meet the needs of its neighborhood, it also receives supplemental energy from remote sources, distant wind farms, geothermal, fusion, and in the case of this region, ocean thermal and wave power facilities also produce and send electricity to the RMCs through underground superconducting conduits. The RMCs within the region also share energy resources with each other through a microgrid similar to the one each shares with its neighborhood service area. Finally, and most surprisingly, some energy is sent from the RMC to users through wireless transmission. These transmissions energize small appliances and portable electronics in the home and office, eliminating the needs for excessive structural wiring in many buildings. Home, as always, is where the heart is. It's also where the heart of energy efficiency is, now a priority for its occupants. Spurred on by the advances in the miniaturization of energy technologies, their integration in building materials, and sustainable design practices, many buildings now produce as much or more energy than they consume. Siting of buildings for optimal solar orientation, rooftop wind scoops, vegetation, and automated clerestory windows all take full advantage of natural light, precipitation, and airflows to illuminate and cool the interior. Solar photovoltaic wall paints and glass surfaces generate energy, while rooftop solar thermal units heat water for multiple domestic uses. Many exterior glass walls feature electronically triggered coatings that allow residents to modify opacity at will, enabling the instant placement or removal of windows of any size. Modular interior walls are mobile, allowing for the rapid reconfiguration of space to suit any function. Furniture, internal decorative materials, and floor surfaces are comprised of recyclable materials such as wood, plant fibers, and resins. Most durable goods are now leased, and manufacturers' take-back and recycling programs have resulted in the practical elimination of all solid waste. Bipiping and separation of water flows from kitchen and bathroom appliances also ensures the continuous reclamation of this precious natural resource. In our sustainable urban system design for the future, human, animal, and plant communities thrive. Our primary goals: optimal usage of our energy resources and our existing built areas, ecologically sound design and development, community commitment, and equal opportunities for all residents have been accomplished. Can we as a society attain this stunning vision? Do we have the will to begin taking the steps necessary? These are the questions we must all ask ourselves. The quality of the lives of our children and our children's children, and all the generations to follow, will depend on our answers.